In this video, I'm going to be taking you through elasticity, a topic in physics. So I want you to stay with me, and at the end of this video, I believe you are going to find it very simple. Now, elasticity. I'm going to be treating this topic following this outline. Firstly, I will introduce. Secondly, I will give an overview of the course. Thirdly, I'm going to discuss on some major scientific contribution. And lastly, I'm going to be discussing the concepts and terminologies behind elasticity. Now, firstly, let me start with introduction. Now, what is elasticity? There's a lot of objects, substance, and a body that exists in the planet Earth, and many of them they exist in some forms, and there are some properties we can discover in them. One of those properties is what we call elasticity and plasticity. And elasticity. Most objects or body that exists on planet Earth majorly exist between these two extremes. Some are plastic, while some are elastic. It's either you are plastic or you are elastic. Anything that exists on planet Earth must exist between these two extremes. Now, let's now discuss on these two phenomena. Plasticity can be like opposite of elasticity, which is our main topic of discussion. Plasticity is a phenomenon that explains the inability of an object or a body to regain its original shape and size after the removal of a force that already deformed it. While elasticity, in contrast, is the ability of any body object to regain its original shape and size after the removal of a force that already deformed it. Now, we all know that force is a pressure applied on an area. When I put my hand here and I grasp it, and putting my hand, which is the force, the energy on the area of my hand, that's the pressurizing my hand, and that my hand is the area, and that's the force. Now, whenever you apply a force to any object, just as you see me dragging the rope of this glass now, as I'm putting force, you will notice that the rope is stretching. So whenever you apply force to an object or a body, it deforms the body, and this deformation occurs on two bases: on the shape and on the size. Whenever a force deforms any object or body, the first thing I will do is to deform the shape, and secondly, to deform the size. Because most matter, both organic or inorganic or any matter that exists, they must actually possess shape and sizes. That's what we are talking about now. So plasticity is the opposite of elasticity. Plasticity is a phenomenon whereby actually you don't have the ability to regain your original shape and size after you have been deformed by a force. Now, that is the general introduction. Now, we have a lot of substance around the rubber band springs that are elastic. When you stress those objects or substance, or body, they actually return back to their original shape and size. But one thing that is important that you have to know the difference between this and this, the plasticity and the elasticity, is that anybody that is elastic, immediately a force is applied, and that force that was applied is removed, it will quickly return back to its original shape and size. While a plastic body, after you apply the force, it will not quickly return to its original shape and size. There will be sluggishness. It will not quickly return back. Then you can say that particular object or body is a plastic. I think that's a nice introduction topic. Now let me go to the overview. Now, with what I'm saying, that means there are two things that you have seen me mentioning since morning, and those two things is force and extension. Extension. It's like force. Let's just assume that force, or let's say force, is the input, while extension is the output. Whenever you apply the force on any object or body, it is the result, the repercussion, the consequences is that there is going to be an extension. And if we have extension, we can actually now give a relationship that the higher the force, the higher the extension. That's what we discovered. That so far, this particular substance is accommodating a force, you are going to have an extension. So imagine this is a spiral spring and I put a small load of 5 kg. The way it's going to extend will be different from if the same spring I apply a load of 10 kg, because the load are different and the weight will definitely be different. So the higher the weight put on a particular place on a particular elastic body, the higher the extension. So you can actually say that the load or the weight is also the force, because both are measured in Newton. So that's an overview of the course. So we are going to be discussing a lot about elasticity, some terminologies. And it's on this basis of what we have been discussing so far that a scientist called Hooke, which is Robert Hooke, actually make a scientific contribution. Now I'm on the third point now. Make a scientific contribution on this our topic of discussion, and his contribution is given as a law, and that's why we have the primitive law. The law is two. We have the primitive law and we have the modified law. Now, the primitive law actually noticed that all elastic substances, I mean those substances that have the ability to return to their original shape and sizes after the removal of a force that already deformed them. Note it that the force that deformed them must be removed. If the force is still there, they maintain their deformation. But once you remove the force, they will tend to go back to their former shape and size. So now, based on this observation, Hooke actually propounded his first law on elasticity, which is the primitive law, on two major focus, that's force and extension. And how did he relate them? He actually puts them in a condition, because he noticed that most of the elastic object or body, they actually have what we call elastic limit. Elastic limit is the extent to which you can stretch them, to which a load can deform them. Once the effect of a load has surpassed a particular limit, the substance will totally lose its elasticity. Even when you remove the force that was applied, that object or body will find it so difficult to return back to its original shape and size. Are we together? Are we together? Thank you. Now, hope you are getting what I'm saying. Yeah, that's nice. Okay, now, the overview of what I'm saying is that the primitive law of Hooke's law only rests on force and extension. And how does he define it? He said he put a condition. Don't forget the condition. Provided the elastic limit of an elastic material is not exceeded. He was saying that my law only is only validated when the elastic limit is not exceeded. Because he noticed that once you pass the elastic limit, his law is no longer correct. So therefore, you must know what is Hooke's law. They can just ask you anywhere, anytime in your secondary school, in your class, in external exam. Hooke's law, the major Hooke's law, the first Hooke's law, the primitive Hooke's law that we all know, states that provided the elastic limit of an elastic material is not exceeded, the force applied on an elastic material is directly proportional to the extension. In other words, the higher the force, the higher the extension. If you apply 5 kg of load, you expect a particular force. But if you increase the load to like 10 kg, you expect a higher extension. Sorry, let me recap. When you apply a load of 5 kg, you expect a particular extension. But when you apply a load of 10 kg, you are expect a more higher extension, because you have changed the weight of the load. That's what we are saying. Now, under this, Hooke's law now proceed and modified the law after further observation. He noticed that there's no how you will apply a force to any elastic object or body without having an area of concern. So you are not going to apply your force everywhere on the object. It must be an area. Now this rope begins from here to this other side. So if I want to drag it, I can't drag it at once everywhere. I only drag it at a side. That side I drag it is the area. So he actually modified the force by dividing it by area, and he modified the extension, which is the result of a force, and divided by length. Then this one he called stress, and this he called strain. So the modified version of Hooke's law states that the same condition, provided the elastic limit of an elastic material is not exceeded, the stress of an elastic object or body or substance is directly proportional to the strain. You can say stress is the force applied, while strain is the effect or the repercussion of the force. And stress is force over area, while strain is extension over length. And as you know, that the unit of force is Newton and the unit of area is meter square. Therefore, the unit of stress is Newton per meter square. And since strain, the formula of strain is extension over length. Extension and length are both measured in meter. We therefore call them a pure ratio. What is a pure ratio? A pure ratio is a ratio in which both the numerator and the denominator have the same unit. So since extension and length have the same unit, they are pure ratio, and therefore their units will cancel out. That's why strain has no unit. Now, this is what we are saying. And stress is directly proportional to strain. That's the modification to Hooke's law. And there is a ratio when you put stress and strain as a ratio, like I mean stress over strain. Stress over strain. We call this E, and the E here means Young modulus. Young modulus is stress over strain. But when you actually express force over area, which is the primitive law of Hooke's, because at the primitive level, Hooke's does not divide force by area or divide extension by length. It's just force directly to extension. So when you now put force over extension. When you now put force and extension in ratio, like I mean force over extension, the constant there is K, not E. Now, stress over strain is Young modulus. Why? Force over extension is called stiffness, or force constant. Just know that Young modulus is stress over strain, while stiffness or force constant is force over extension. That's what we are saying. Force over extension. I hope you get what I'm trying to say since the beginning of this video. The recap is just that elastic substance and plastic substance are opposite, and most substance in the biomass on planet Earth exists between these two extremes. Is that if you have any object, any body, is that they are plastic or they are elastic? But our topic of concern is elasticity, elastic substance, and I have discussed I introduced us to the topic, and I actually give us an overview of what we are expecting. And I discussed the contribution of a man called Hooke. So in the next video, we are expecting the concept and terminologies of elasticity. I'll be explaining deeper the concept behind elasticity and some terminologies you have to be familiar with that will be asked in your exams, both internal and external. Please do well to subscribe to my YouTube channel, UGradus Education on YouTube, and also sign up on my website, https://ugradus.com. See you next time. Love you.